Hello students, welcome to Harita Math Tuitions. It's been a while since we met. I was really not getting time to upload any videos. So I wanted to upload this video from direct and inverse variation, which is a special question on compound proportions. So generally we have seen direct and inverse variation in all the problems of this chapter, but we have not seen an example of compound proportions. In compound proportions, we see three quantities, wherein we actually try to observe that there are either two direct proportions existing or two inverse proportions existing or one direct or inverse proportion existing. So in this particular problem which is given over here, let's see what kind of variations or proportions are existing over here. So generally in compound proportions we see a comparison between three or more quantities. Now let's look at this question to have a better clarity over the better clarity over what I said. So 24 workers working 6 hours a day can finish a piece of work in 14 days. So there are 24 workers who's working for 6 hours a day. They are working for 6 hours a day. They can finish the work in 14 days. Now we would like to find if each worker is working for 7 hours a day, okay, and they're going to complete the work in 8 days, how many workers are required? So let's see what we're going to observe here. Let's see what we're going to do here. So let us write the three quantities which are given: workers, hours and days. Now 24 workers are working for 6 hours a day. They can finish a piece of work in 14 days. We don't know how many workers we need to complete the same task in 8 days if they work for 7 hours a day. So what you do is, you got three quantities, right? So wherever you use your x, that means workers, you have x. So you compare this with hours and days. So compare W and H and W and D. Okay. First let us make a comparison between W and H. So observe here. So every worker is working for 6 hours a day. They can complete the task in 14 days. If they're working 7 hours a day, definitely we require less number of workers. That means one quantity is decreasing, other quantity is increasing. Workers are decreasing, hours are increasing. So it is inverse variation. In inverse variation, you see that one quantity rises, other quantity decreases. Okay, W is inversely. This is the symbol for inversely proportional. Now what you do, you compare a W and D. Okay, so what's happening here? So for 14 days you require 24 workers. For 8 days to complete the task, definitely you will require less number of workers, isn't it? So more number of workers. Because if you want to finish the task in 8 days, we appoint more number of workers, right? So days are decreasing, workers are increasing. Again, you see the inverse variation of even this also. So you got an inverse relation over here and over here. That means it's an example for a compound proportion in which you see inverse variation twice. Okay, you might see direct variation twice also, or you can see one inverse variation and one direct variation also, depending on the problem. So from here we can write W is inversely proportional to 1 by HD. So what do? I send HD to here. It becomes WHD is directly proportional to constant. Is directly proportional to 1. Right? That implies what? WHD is equals to constant. So W1 H1 D1 is equals to W2 H2 D2. So clear? So now you substitute the values and find out the W2. So it is 24 into 6 into 14 is equals to x into 7 into 8. So x is equals to 24 into 6 into 14 by 7 into 8. 7 ones are, 7 twos are, 8 ones are, 8 threes are. X is equals to 18 into 2, which is 36. So we require 36 workers who can finish the task in 8 days. In 8 days, working for 7 hours a day. 7 hours a day. Okay. This is the question from direct and inverse variation, which is dependent on compound proportion. If you like my video, please share and subscribe to Harita Math Tuition. For notifications, please click the bell icon. Thank you so much.